So, female, male. Okay, so you got 7, 6, 3, 3, 5, 7, 8, 6, 1, 1. Alright, so obviously, I'm kind of leading you a bit to do the right thing first, of course. Probability is all about parts out of the whole, so I want to know all the totals of all these subcategories so I can answer everything.
Okay, so I got 13.
Yeah, 13, 6, 12, 14, 2, and then 10, 24, 23. Yeah, 23, so then you get to 47 people. I like it. So the question is about, there's part D, probably female or T-Mobile. So probability of fort. And what does or mean? Is or the nice bouncer or is or the mean bouncer? I don't know if that helps you. Or is the nice one. Yeah, you add. So it should be a larger number. And should be the one that decreases. Because you have to meet all the requirements for and. So and means multiply if you don't have the stuff to count. Any probability question I ask you, you don't have to use the formulas at all. If you just count what's going on.
Oh, yeah.
All probability is based on counting. But I have given you problems before where I didn't give you anything to count. It was just probably A is 0.8, probably B given A is 0.2, whatever. So you had to use the formulas because you had nothing to count. Here I've got everything. I've already counted a bunch of crap. I should be able to develop all these probabilities without really a formula, to be honest. So if I'm the bouncer and I say to get into this club, you got to be female, or you got to have a T-Mobile device, right? You with me?
Yeah.
So I'm a dude, but if I had a T-Mobile, which I don't, if I did, can I get in the club?
Yeah.
Yes, of course.
You're part of the-
I'm not a female, but it says or.
Oh, okay.
So what if I'm a female, but I have Android from Verizon or something? I can still get in the club because I just got to be one of either one of these. So all these people can get in, and all these people can get in. But of course, if I do 24 plus 14, what have I done wrong? Yeah, there are 8 people that are counted twice. So if I let all these people into the club, these 8 people are already in there. You guys get an idea for this? So then how many more people am I going to let in the club over the 24? I'm going to let 6 more in. So you could either do minus 8, but what is 14 minus 8? Freaking 6. The other ones that you haven't let in the club yet. So there's a lot of ways to look at this. I got to let all these people in, right? I got to let all these people in because it's an or. So who's going to come in? These people or those people? I've counted these twice if I add the total, so if I want to be smart about it, I can just, instead of doing this, I can just say 24 plus the 6 that I haven't counted yet from this other group. Either way, it works the same. The math doesn't care. This math is like, okay, 14 minus 8 is 6. Good job. But that's a kind of a different way to look at it. So this is using the formula, which you don't need. This is just, using common sense. Those people, the people I haven't counted yet from the other group, gives me a total people. So 30 out of 47, and then whatever the hell that is.
I thought you had to change the denominator and do something else.
No. You're thinking about, like, number 6. So what's different about number 6? This one is about picking one person. Number 6 is about picking 2, and that's when I have to be careful. That's a situation where I do want to use a formula idea because I'm picking 2, not just 1. So things might change. Yeah. The other's probably that one person is female or T-Mobile. I can just count the ways somebody could be that. And then the other question was about like a given. If I said what's the probability that they have Sprint given that they're a man, for example. Don't look at the problem. Look up here. I don't even remember what the problem was on there, but who cares? Probably Sprint given that they're a dude. So what do I know about this person?
Who's male?
They're a dude. Given that they're a dude. Okay, so how many people am I talking about?
23.
23 people. So out of those 23 people, how many match what I'm looking for? 3. And whatever the hell that is. So what's the thing about that? Why is the bottom here 47?
Oh, it's everybody.
Because it could have been anybody. I didn't know anything about them, so how many people could it be? 47. So out of those 47, how many match am I looking for? Blah, blah, blah. Given that it's a dude, so now I know it can only be out of these 23 people. The bottom is always the total number of things it could be. And I know it can't be any woman because I know it's a dude. Dude. So what's probably that it's a female given that they have T-Mobile? So now what's the bottom going to be?
24.
No. Nope.
No?
What am I given about the person? The probability they're a female. I don't know if they're a woman.
Okay.
Given that they have T-Mobile.
Okay, 14.
Yeah. So the men, 23. The T-Mobile, 14. Out of those 14, how many are women?
8.
8. Cool. So the idea of probability actually never changes. The bottom is the total it could be. The top is how many match what you're looking for. Always. It's kind of crazy. So if I can count those things, I don't have to really use a formula. I can just use the idea. Just build it.
Have you done it before? See.
4C. No.
Yeah.
So we got this here. Any other questions on that? I'll take that as a no.
It's a good refresher, though.
So something that will help you out a lot here is to remember what you always do first. What do you always do first when you're factoring? What do you always look for first? GCF. Yeah. So is there anything that all three of those have? Yeah, they all have some number of W's. How many W's do they all have? 2. Every single one of them has at least 2 W's. So I can take 2 W's from everybody. So I can take 2 W's from everybody. So now there's how many left here?
4.
4. 2 less. Took all his. Too bad for him. Now, notice the powers. I don't know if you guys remember. But if I'm going to write the result here, what would go here?
2.
Yeah, W squared. So in order for this to work, that power has to be half
Yeah.
of this one, because that's the first thing I would do, is I would cut that in half. So if that was a 3 or something, it wouldn't work. Not this way, anyway.
So if it was a 3, you wouldn't do the next step.
If that was a 3,
Yeah.
then I couldn't do it the way that we know how.
But you're cutting everything on the top in half, like
No,
20,
no, I'm not. No. So how do I factor this? What do you put here and here?
2. I mean X, and then
Yeah, why do you put an x there and an x there? Because you cut that in half, put part. Yeah. So if it was x10, you would put x5, x5. That's according to the factoring rules that we know. I want you to realize something. I mean, I've said, sometimes I say if that was this, we couldn't do it. And I always try to remember to say we couldn't do it according to what we know. Because there's a lot more methods to factoring than what we talked about. We just barely got into it. So don't just think factoring. What good is factoring? You have to be specifically, no, there's a bunch of other shit I could try. We just didn't get that far. Some of you guys are like, oh, that's fine. Damn. So now that I've cut that in half, that's the same as the middle term. That's beautiful, because the middle term is going to come from that plus that. So there better be freaking w squares in the middle. Now I just got to make the numbers work. What numbers multiply with 28 had to be
Negative 7, negative 4.
beautiful. They both have to be negative. 7 and 4 do it, and they both have to be negative. Now if you circle that, and then take points off. Just
You can
because
factor that into
I'm in a bad mood.
minus
Huh?
2.
Say again? Yeah.
W minus 2.
Beautiful.
W
This is
plus
not done yet. That's done as far as we are concerned because I can't break 7 in half nicely. So that's not quite a difference of squares because 7 is not a square, but 4 is a square. So the w squared is there. The w squared minus 7 is there. And this dude goes to what?
W plus 2 minus 2.
Mm-hmm.
Kick ass.
Does it matter if the plus 2 goes first or second?
Doesn't matter at all. In fact, the whole order that I did doesn't matter at all, except for this guy. Anything that's a single term we normally put in the very front. But all these could be, who cares? Because 7 times 3 times 5 is the same thing as 5 times 7 times 3 is the same thing as, multiplication doesn't give a shit what order you put it in. I like it.
Awesome.
So,
Part D is based on what we just did, sort of, because notice how did I know from the beginning? How would I know that this could go further? Because the power was high enough to be cut a couple times. It just depended on the number that ended up here. Right? This couldn't go any further because 7 I can't cut in half nicely. But 4 I can. If this would have been a 5, I would have stopped here. But I knew I had a chance to go further because that power was higher than just 2. It can be cut multiple times. So look at part D on number 4. That power is much higher than 1. So maybe this can be cut multiple times. And yes, that's how that problem works.
I forgot.
Mm.
I just left
So if you haven't tried 4D yet, give it a try right now. And then we'll talk about it. My camera didn't record my one lecture, my one class the other day at all. I was like, well, shit.
And this angle.
Yeah, he seems to be doing good.
If you're-
What's it wrong?
I have a question.
What about that?
Not that one. This is 4.
What else comes out, though? They both have a Y, but they also both have a number. Exactly. 10 and 90, they
No
both
entiendo lo
have
que estoy haciendo.
10. Yeah, so you get to the 10.
Alright. And then you watch there.
Minus 9, see, and that can go further.
That'd be okay.
Does it come out having like 4 things at the bottom or no?
Yes.
Yes, okay.
2,
I
4, yeah.
think of it. No, I'm not.
I especially want to do this one up on the board because I didn't have enough room there on
Yeah.
the answer.
Called up by this.
Oh, you didn't do it? On the...
I did, but you can't really read it too well.
How good is that? Just kidding. So, it would be the answer if it doesn't have any exponents that you could split in here.
Do it again, a second. Oh, so if it was like x to the 7th or something?
Yeah, because like I don't know like if that's like just the answer or like or I could just continue.
As long as you can keep, as long as it's in a form that we can do something with. So right now it's a difference of squares.
Mhm.
But once you do that form, you say, oh, this one is a difference of squares also. So you keep going.
And at the
So as long as that keeps happening, you gotta keep going. So if it started off as x to the 7th minus 1, I couldn't do anything.
Oh, sure.
Or at least not for us. We couldn't do anything.
Not first.
So what's the first step?
X1 minus 1 plus 1.
So which one of those can go further? See, both of them, no.
No, that's the negative.
Yeah, just this one because that allows for different signs, which makes the middle term cancel. So this guy stays the same. He just comes for the ride. He just comes for the ride. This guy can be split up. Same way we did that guy.
X squared.
Yeah. So now these two are done. They're sum of squares. I can't do anything with them. At least not using real numbers. So they're just going to sit here and wait.
Wait.
This guy, again, can go freaking further.
Just because it has a negative?
Yeah, because everything's cut. You can cut it in half and there's a minus in the middle. So it's a difference of squares. And of course, that's just going to be...
X.
So you didn't touch the positive side whatsoever. You just
Yeah, why not? I didn't feel like it. It would have made it too long.
you didn't
No. No.
Oh. I was gonna say okay, me either.
I love it. I love it. So if you try to do this, if you try something, it's got to be something like x plus 1, right? But then you get plus 1x plus 1x is plus 2x's. That exists here. So this cannot be equal to this because they don't end up being the same expression. So then you go, oh, all right, what about minus minus? Nah, Jeff, nah. Negative 1 times negative 1 is plus 1. But then negative 1x minus 1x is minus 2x, which doesn't exist there. So I desperately want you to know, why can I do this? Because of the fact that I have two numbers that multiply me negative, they have to be different signs, which means when you add them, they will cancel. If it's a plus, everything I just said is not possible. They have to be the same sign. If they're the same sign, will they cancel when you add them? No. They'll just double, right? So that's why you cannot do a sum of squares. It's the exact same reason why you can do a difference of squares. Okay. Yeah, my students pick up on that. But now you may be Tai Chi, Mike. I should have asked her to speak up louder. We could have two things. Jackie wasn't in our class that had the Spanish teacher next door.
Yes.
Yeah. There's a door between the two classrooms, and she was standing next to the door of lecture, so we'd be getting double lecture.
Everything. Clearly. And I was like, yeah.
Yeah, so we're getting two languages at once. We have Spanish and
Free Spanish immersion class.
yes. So you guys can ask any math question you want to. Anything's been bugging you, anything that doesn't make sense. Anything.
I'm just trying to figure out, I'm back on the 1B, like trying to see, I have an answer because we did that yesterday, of course, but I'm trying to, like, I don't understand why I flipped the X1 and 0.
Oh, okay. All right, let me show it to you a little bit different way than what because I already showed you. I don't know if you remember. We went over why a negative power means what it does. I don't know if you guys remember. So what we did was something like this. What would I put on the bottom to make the result this? What would I have to put down here to make the result that? So really the question is 3 minus what is negative 1? No. 3 minus 4.
4.
Yeah.
Yeah.
So if I put a fourth power down there, that's the result. Is everybody cool with that? We know this property of powers, right? You better, because then we use it to build up the property of logarithms. When I divide like bases, I subtract the powers. But when I have multiples of things, can't I just cancel them out? So isn't this x times x times x over x times x times x times x? So don't 3 of these cancel? So there's one x left where? So these have to be equal to each other because they're both equal to this. There's a slightly different way to look at it. So what's a negative power mean then? It means flip. But let me show you a different way to look at it. So what if I have m to the negative 3? What's it over? What's anything over? 1. 1. All right. Now, again, this is just feeling out what it could possibly mean, right? This is something that students are not used to. I mean, if I hit something I'm not sure what it is, I play around with it. I throw shit at it. I see what it does. I try to do stuff to it to see what it is. So I don't know what the hell that is. So let me try. How would I make? I don't like negative powers. So how would I make the top cancel? Like how would I make it become m to the 0?
Times 3.
M to the 3rd, right?
Yeah.
So whatever I do to the top, I better do to the bottom. So on the top, I get m to the
Nothing.
0. And on the bottom, I get m to the 3rd. And what is anything to the 0 power? 1. Kind of a different way to look at it. Do you guys see that? But what I just proved, m to the negative 3 equals 1 over m cubed. I could have done it starting with 1 over m to the negative 3 and did the whole thing, and it would have become m cubed on the top. So what does a negative power mean? Wherever that thing is, you flip it. That's what a negative power means. There's an analogy there too. What does subtracting a negative mean? It actually means that you add. So what does dividing by a negative power mean? It actually means you multiply. They kind of like undo each other in much the same way. Okay, some of you guys got that. Okay, cool. So what that translates into in the long run is much the same way as this. If I have a whole row of shit to do, and I see somewhere 2 negatives in a row, blah, blah, blah. Right there, I can make that plus, can't I?
Oh, yeah.
And then I do the rest of it, right? So, if I see a problem like that, I do the same idea. Anything with a negative power, I move to the other side. So these 4 m's can go down. These 3 y's can go up. Not can, but they just do, because that's what a negative power means. So then I'll rewrite the whole thing. 18. Those 6 y's are still up here. Those 3 y's came up.
Okay.
12. Those m5, that 5 m's are still down there. They become a 3. Okay. And those 4 m's come down. It's almost exactly the same thing as first making those 2 negatives a plus and then doing it. Right? So almost the same thing. I know some of you guys don't believe me at all yet. I think the same as that shit, but it's the same reasoning. They're opposites somehow, right? So now I just reduce, put my y. So how many? What's this?
Let's see. 3 over 2.
Good. And real quick, what's 18 minus 12?
6.
6. So that's a cool little trick. You're trying to reduce something to the difference, and that number might be what goes in, or some part of that number might go into both. Because how do multiples of 6, how much are they apart from each other? 6, of course. Right? So if they're 6 apart, they might both be multiples of 6, or they might be multiples of 3, or they might be multiples of 2. That's a neat little trick. If you forget it, you can still reduce. But how many Y's do I have up there?
9.
9. How many M's?
9.
9.
Alright.
I'm telling you you're wrong in German, but it's 9. Cool.
Got a question. For 1A, making 3 1/5, did you make that into, you make that into like 16 over 5, but then you like make it.
And then the next step is to make the LCD.
Yeah,
Yeah.
it should be 10, right?
Yep.
So then, do you, with the
Multiply top and bottom.
16, do you, you multiply that by 2?
Well, 5 needs a multiple of 2, and whatever you do to the top, bottom, you got to do to the top also.
Okay.
Yeah. Now, please don't forget, I mean, we had that extra paper that was a review of stat stuff. And then we had the lines, the graphing stuff that related to the data points and all. Those things could also be on the final. This itself
Right.
is not a complete final practice sheet.
Formula sheet.
It's an extra practice, huh?
Formula sheet.
Yes. Yes, sure. Yeah, we haven't done that yet, right?
No.
Okay. Hey, how many formulas? Notice that I didn't put the sequence stuff on there. I'm not going to put any of that on the final, to be honest. Remember the arithmetic and geometric sequences some of you guys made?
Yeah.
Alright, I might put it down there as a bonus. So the only real formulas, I'm gonna give you the standard deviation formula for that problem. Okay? What other formulas do you think we need down there? I mean, you gotta know the equations for lines.
Right.
You gotta know the quadratic formula. I told you you have to memorize that. So any suggestions on what beyond those should be on a formula sheet? I mean, if I was going to put the sequences down there, there's those 4 equations. I think that's almost the only formulas we've had to use. Now, probability formulas, right? So we can write those down. So or, of course, basically means
Or was.
is it add or multiply? Add. So it's probably A plus probably B, but then you got to adjust it because there might have been some people in A and B. Remember that?
Yes.
The only time I would use this formula is if I don't give you the numbers to count. I don't know if that makes sense. So you've seen problems for me where I said probably A is 0.7, probably A or B is 0.2, figure out, Then you got to plug it in the formula because it's just a plug and chug thing. I didn't give you anything to count. I just gave you the probabilities. And the formulas are how the probabilities relate to each other. A given B.
Why can I be an English teacher's
Shut up. And then A and B, we actually just steal it from this kind of format. It's probably A times probably B given A. Hopefully those look somewhat familiar. This is actually exactly what we do in like number 6. Probably the first 2 times probably the second 2, given that the first 2 happened. So if it's without replacement, this guy changes. it's with replacement, they're actually independent.
Two A, no, 1B, actually. Since it has 3 minus 5 cubed, does that mean that there's just 3 of those, so then you have to,
No,
or you put the cube into the...
no, good, no way in hell.
Stripping out,
Yeah, you are. All right, so far, I mean,
You do that one? I got an answer.
Yeah.
Right.
this is all we have for the formula sheet so far. You can suggest anything else if you think about it. So here, the first time we had to FOIL. The first time we ever had to FOIL is when the inside was something I could not do.
Yeah.
Then I need a way around order operations. What does order operations say you do first? Parentheses. You do in the parentheses first, which I can do there. I couldn't do it here, so I have to write it and then FOIL and distribute.
3 minus 5.
But here, what am I cubing? Well,
2.
We don't know yet.
well, no.
Then we gotta figure that out.
What am I cubing? -2. So please, dear God, don't make it 27 minus 125.
Yeah.
Right? Cubes are based on what operation? or any exponents based on what operation? Multiplication. So it will not play well with subtraction because it's not based on subtraction. I really want that to make sense.
Ish.
So now what's -2 cubed?
-8.
Good. And then this you just do. What's the very last thing you do in this problem?
Subtraction.
Good. So that 5 minus is just going to keep on. Because it's 5 minus, I don't know yet. That big old chunk of I don't know. So what's -2 times -8? It's not shit. No C shit. 16? I like it. I mean, the big mistake people make is they put 24 here and then you screw yourself over. Remember, why is that not fair? What's the only thing that I'm dividing by? What's the only thing that would be on the bottom? What's the only thing I'm dividing by? 8. I'm not dividing by 24. I'm dividing by 8. And then multiplying by 3. I'm not dividing by 24. It's not fair. I don't know if that makes sense to you when I say it's not fair. I always think of it like this number's trying to be big, and it's like, oh, I'm divided by 8, and somebody puts 24. That's not fair. Wait a minute. It's supposed to be bigger. It's a shit. So it's only divided by 8. It's not divided by 24. Do it as it comes. So remember, PEMDAS could have been PEDMASA. It's just easier to say PEMDAS. The MD does not mean multiplication and then division. Hell no. You actually do either one as it comes. So then it would be 5 plus 2 times 3. 5 plus 6.
If you do it with 24, you'll get 0. That's weird.
Well, no, you don't. It would be 16 divided by 24, which is some fraction, right?
It's a weird fraction. Yeah, I see what I did.
All right.
So, I'm good.
Yeah, I did the 11 thing, or the 20 thing.
And I've heard and I've seen evidence that there are actually teachers who teach multiplication comes before division, which they should be the hell out of this field. You're screwing people over. You're screwing people over, and they're like, students hear this, and like, they don't even know what they're doing. At least math teachers, but get rid of the dumbasses, and it'll be a little bit better. So there are some teachers who are dumbasses. Shouldn't be teaching. Gee, do I have a strong opinion? Yes.
Maybe.
So I'm sorry, I was clocking right through somebody. So I have a question about. Yeah.
Ask, like, how many questions are
So for a regular class, how much time do we have for a
It's,
test?
an hour or so. However long class.
It's 8:30 to 9:45, right?
8:39, 55, so like almost an hour and a half. So the time we have for the finals is 2 hours. So the final's going to be a little bit longer than a regular test.
From 7:15 to 9:15.
You got it. Totally. All right. You guys with me? So however long the regular test is, the final's going to be a little bit longer. So normally about in the upper 20s of questions. You know what I mean? I'm counting A, B, C, Ds.
You said we're not really use those formulas that are up.
And again, what's my point with that? You use these formulas. You can use them always. But they make certain problems harder. And then students hear me say that and like, well, what the hell is the use of formulas? And well, not only do the formulas exist, you have to know when to use them, right? So if I have a situation where I can count everything, I'm not going to use any of the freaking formulas at all. I don't have to. We did a lot of problems before we did problems, and then we figured out what the formula would have to be. So we did them before we even knew the formulas, right? So what do these exist for? If I just tell you probably A is 0.5, and probably this is 0.7, and probably this is 0.91, and then you got to solve for the one you don't know. You've seen problems like that for me. Yeah.
Are we going to use the sum formula at all?
No. I decided I'm not going to focus too much on that. It's good that you guys saw that it existed. We talked a little bit about Fibonacci sequence. I hope. Did we?
Yes.
Fibonacci sequence sound familiar?
Isn't that that thing where it's a spiral?
Yes, it's related to a spiral. I like it. Kind of related to the way that the chambered nautilus sets up its shell. Sort of related, not exactly.
Inequalities, no.
Oh, that's right. That's something else I didn't put in there. So definitely there could be inequalities on there. What's the only thing with inequalities? There's two things. There's the fact that you have to graph them at the end. And we're using the closed circle, open circle, unless you want to use the parenthesis in the bracket and make me go, oh, so awesome. But you can use a closed circle, open circle. But the other thing, of course, is this idea. How do I solve that? What do I do?
Oh, you just treat it like a regular equation. You're going to do a plus x per minus 5, right?
So what do I do to both sides?
Multiply or get rid of move the negative.
Okay, so I can divide both sides by -1.
Yeah. So this is
So x
then you flip the sign.
total. Good. Why do I flip the sign? Because negatives. That's how they work. That's how numbers work. And variables are numbers I don't know yet, so they have to work the same way. You guys remember that? Because which one's bigger? 2. When I divide by -1, I get -2 and 1. Which one's bigger? 1. What happened? Oh shit, so I better do it all the time. So when you multiply or divide by negative, not there's a negative in the problem somewhere, but when the number I multiply or divide by is negative, I have to flip that. Because I change the side of 0 I'm on, so the bigger one becomes smaller and the smaller one. The order changes when I do this. I change the side of 0 that I'm on. Does that make sense?
Not when you divide. I mean, not when you
When you multiply or divide by a negative.
divide a positive. You don't switch the sign.
No.
No.
Yeah, because here, I can. Which one's bigger? 4. And if I divide by +2, you get 2, -1. Which one's bigger?
2.
Still the same side is bigger, of course, because I didn't switch the side. Let me see. I really want you to get this because this explains technically what's going on. So here's where's the other one? 2 and -1, right? So 2 is bigger because it's that way. But when I divide by -1, that goes there and that goes there. So now they're on other sides of each other. That's why the sign is a flip, because the relationship flipped. Oh, you guys like that one. So what you can do for yourself is if you have a problem where like, oh, there's Jeff trying to make it all negative, dorky, Jeff. What you can do is just don't let it be negative. Add 4x instead of subtract x. If you really, really hate the negative thing that much, don't let there be a negative. Right? So if I did this, what would it be? Plus 4x, minus 2, minus 2. I get 5 greater than 5x divided by 5. 1 greater than x, which means x is, if 1 is bigger than x is less than 1. Why do I turn it around? Because of the variables on the side, the arrow points me in the direction that I shade. Yes?
Not related to that, but if I had a -6 over a -5, would that just get rid of the negative?
Totally. Yep.
Nice.
Yeah.
Mean, median, mode, and range, and standard deviation is also going to be on there.
Yeah, like I said earlier, this one sheet does not encompass everything that's going to be in the practice, on the final. We had that other sheet that focused on reviewing statistic stuff, right?
Yes.
And then there's going to be all this stuff. And the one thing I didn't put on here, inequalities, they're totally going to be on there too. I like it. So the best way to study for this test is to look at the practice final, but to also look at all your tests. It's the best way really to study quickly.
Yeah.
Yeah.
Cool.
And of course, the next thing you do is do problems out of the chapter reviews, because all the answers to those are in the back. Has everybody tried out the Math Study Center this semester at all?
Yeah.
Were they able to help? Yes? Okay.
I was trying to cheat at first, but it was cool.
They did what now?
They thought I was trying to cheat.
Oh. Did you have to come, somebody had to come see me and
Yeah.
have me write it
I
down?
did.
Yeah, okay. I just forgot that.
Besides that, it was cool.
Alright.
Yeah, another problem like 1F with the square roots and the whatevers.
Oh, yeah, it gives me free reign. Square roots and the whatevers.
I don't know how to describe that.
I got you. What you got, Jeff? So what are you trying to do with this? If you do so, square root of 18, I don't know what the shit is. It's a little bit more than 4, because 18 is a little bit bigger than 16, but it's not what I'm looking for. And please, to God, if you put a decimal here because you're stuck in a calculator, oh my God, you're losing all the points. All right? The old calculator passes the class, and you take this class with it. So what do I do with this? What am I looking for then?
You have to find like a common.
Yes, a number that's square rootable, that's in 18. So I wouldn't break this up as 6 times 3. Even though I could break 18 up that way, neither 6 or 3 is square rootable. Why would I do that?
3,
I do 4,
6, only have to have 3.
16, and
18 is 9 times
oh,
2. There we go.
Oh, so
9 is a square rootable number.
Okay. Oh, square rootable. So
Yes.
you have to break it down in basically every time into 2. Like you try to get it down
Yeah,
as small as possible.
So if this was a cube root, which I won't do to you because we didn't have a lot of cube roots, but if this was a cube root, I try to see if 8 goes in because I could do the cube root. Like 27 because I could do the cube root. 64. I want to use numbers that I know the root can attack, and then the rest of it's just going to be left inside. It's the same way you could actually do like 9/4. Instead of doing 4 goes into 9 and see the remainder bullshit, you can say, well, 4 would go into 8, and there's an extra 1. 8 divided by 4 is 2, and 1/4 is left. Okay, shit, it's the same thing we're doing with radicals. We're saying there's a part of it that I can do the root of, and then there's extra shit, the remainder. Right? And then what's... Now, what's going to be left in here? What's the square root of 9? 3. What's the square root of 2? I don't know. So how do you think I want to break 32 up then? There's a hint there. Yeah, 16 and 2, because I know I want to have a 2 left in there. Or I want to try this anyway. So what's the square root of 16? 4. And what's the square root of 2? I don't know. Now, will the 2 work for this 2? 2 goes into 12. 6 times. 2 and 6. Can I square root either of those? No. But how else can I break this up? And what's obviously 4 and 3? So minus 2 square root of 4 square root of 3. Minus 2 times square root of 3. So that's just not going to be a like term with these. Oh well. It's going to be off by himself in the corner. So we got 3 rad 2s plus 20 rad 2s minus 4 rad 3s. So my like terms are the rad 2s. How many rad 2s do I have total? 23 rad 2s. And I got minus these 4 little rad 3s over there. So we did an example like that and somebody brought up what if it wasn't the same? Well then it just wouldn't be like terms. You just couldn't put them all together.
Are we gonna have any word problems?
Yeah. Bless you. So a big part of yesterday was focusing on the word problems and how to set them up. People just come at it with the attitude already that, well, they're impossible. So I think a lot of times people don't even give it a real try. Plus, I understand you guys don't see the importance. I understand you don't. And that's exactly why it's so important, because you don't know it until you know it. Until you know the math, you have no idea what you can do with it. Sounds like a very teacher thing to say, but
You are a teacher.
there you go. That explains it. Yeah.
Can you do it next week?
Oh, so, and whenever I have some little part times another part, it doesn't matter how many terms they have, which is why FOIL is foolish, but what's the actual idea here? Not FOIL, that's crap. What's the actual idea here?
Distribution.
Yeah, I've got a couple of things that have to each get a turn to distribute. This is so much better way to look at it than, you gotta memorize FOIL, you know, it's crap. It just makes students think, oh, I gotta know songs and I gotta know little words so I can manage math. That's crap. I gotta distribute that. So that's what I do when something's in front of something else, is I distribute it. And then there's another piece that gets a turn. So what's 2x times 4x squared? 2x times positive 6x. What's 12x? Squared.
Plus 18.
Yeah, and then 2x times 9 plus 18x.
Minus 12.
Good, I like it. So now this guy gets a turn. Negative 3 times 4x squared is negative 12x squared. I'm just going to line up my like terms as I go.
Minus 18.
Yeah, minus 18x.
Plus 27. Or minus 27.
Yeah, minus 27. Man, so this is an example of that cubes thing. What? Shit. Because that would be 2x, 2x, 3, 3, 3. Middle, opposite sign, product of the two sides. Did you have to know that going into this? No. But that explains why it all canceled out, because this is exactly the way you would set up a cubes. Again, did you have to know any of that to do this problem? No. You just do it and you go, holy shit, a lot of it canceled.
Question from this real quick.
You know the extra one I used, by the way?
Extra what?
Just another practice set.
Oh, no, I think I gave all my blank ones.
It's fine if you don't. I just think
It's gotta be fine, right? Oh, wait a minute. No, shoot. Oh, well.
I like having the practice and sit right there.
What does it mean this grade, of course? Is this math or class or something?
Yeah.
Oh. Bullshit. I didn't know that.
On your syllabus. That's the one shirt I don't have yet that I need to get.
Oh, this is by itself.
You're-
Yeah, it's by itself.
Syllabus.
So as long as we, I've never done it. It's just, as long as you have the C pass.
Get rid of these.
I never got that.
Oh, yeah.
Yeah, so I'm waiting
I have
for
an
it.
extra. Yeah, that's my trick to keep people here so you actually get something is to not give you the answer sheet too early. Teacher's job is to trick the students into doing shit that will help them.
Good. Okay.
Yeah, I had no idea.
Oh, yeah.
It's funny.
It's actually a bit of a debate right now in the math department about whether, because this course is still, that's why it's got the 298 number, is that's the number set aside for experimental courses. So this is the second semester that we're offering this course. So one of the debates is, if we put a little bit more math in there, will we be comfortable with making it a graded level course?
Yeah.
So right now, it's just not enough algebra to make it to the level of a graded level course. Because, yeah.
I felt perfectly challenged. I don't know what the big deal is. I sweated over all my homework. Why is this not worth a credit?
Yeah. Well, I mean, my math 88 students say the same thing, right?
Yeah.
But pre-algebra not college level, so.
I don't like the same thing. Then that was.
Oh, you just left off the divided by 3 whenever you haven't done that yet.
I always forget something.
Yeah.
That's why I was like, where did you get that from?
My saving grace more than once has been writing down what I'm thinking, so if I get a totally wrong answer, at least I'm not going to keep punished for trying.
Yeah, you would get something for that, but
Yeah,
you lose a chunk for leaving out half the problem.
yeah. I went over one because I did the